This is Siemens TIA portal, which stands for Total Integrated Automation. This is version 15, which is the newest version that they have out. So what we're going to do is show you all the similarities between RS Logic 500 and of course this, which is a new version of the software. So first thing we'll do is we'll create a new project. Now this is different than RS Logic 500, and it's asking for the project name before you even start. So RS Logic 500 is kind of backwards. They don't ask you for the name until you get ready to upload it, or if you save it. It's a good idea to do that, by the way, instead of waiting until you upload to allow it to give you a name. So by default, it's going to just give it a project name, but normally this is where you should give it a name on something where you can tell what it is next year when you come back and look at it, right? This is where it's going to put it at. By default, it's putting it on my C drive. But if you had a USB thumb drive or your company had a server, a file server where they wanted to put all this stuff at, this is where you'd select that. By default, it's the name of the person that's logged into the machine, their username, so this is where you'd save that. And then we'll create this. I'll add a project open just to make sure I remember how to do it. So what's the first thing it's probably going to ask us for? Yeah, probably the type of PLC, but it comes up and gives you a list of ways that things go. So when they call it a portal, it means it gives us the ability to have a bunch of software in the same package. Where RS Logic 5000, you got these little applications that you have to figure out how to run. Oh, I'm sorry, didn't want to do that. We're going to add a device. So right now we could add a controller or we could add an HMI panel. I'm not sure about the PC system. So we're dealing with the 1200s. So I'm going to click on this. And then in the CPU. This shows you how it's powered. This is very powerful with PLCs now. So AC/DC relay means we input AC correctly. It's got DC input and got relay output. Ours is a DC/DC/DC 1214C. So that would be this guy right here. And then of course this would be the model number. Where would I find this information at? Yeah, on the right side of the PLC. So it's this one right here. And then we'll come back here and say add. Then what's the next thing we're going to do? Next up, we'll configure if we got any additional I/O ports here. And we do on this one. My camera's not working really well. So I'm just sorry it won't focus in. So here's the actual PLC. It's got 1, 2, 3, it's got 8, 9, 10, 11, 12, 13, 14. It's got 14 inputs, and it's got 8, 10 outputs. And then we got this module right here, which is an I/O module strapped onto the side. And we don't have any inputs hooked up to it. So if you take the PLC 3 class that we're offering in T2, we'll add this module to this thing. And like I said, I'm sorry it won't focus in. That's close. Another thing about Siemens PLC is their I/O goes in bytes, where Allen Bradley goes in words, right? You understand that? So this has 0 through 7, and then it goes 0 through, then it goes 0 through 5, which would be the second group of 8, but it don't quite complete 8. And we'll show you our address is a little different. This guy here is strictly, it's strictly remote, where we switch it between. Right now it says it's in the run mode, and then this is the era, and then this right here is maintenance, which I don't really know. This has got a little I/O switch that you can put into the inputs. This powers up off DC, so I've got my power supply hooked up here. It's a 24-volt supply. I'm bringing it into the 2 inputs, L plus and M. M is your negative, and L plus, of course. So we're powering it up, 24 volts. Oops. So here's the hardware catalog that I brought up. So we're doing a DC input, DC output, and then we're doing a DC. We're doing 8, 8, and then we're doing this guy right here. And where's that information at? Where would that information be at? On the side of the module, on the right-hand side of the module. And we're going to stick it in that slot right there. Okay. So we've added our I/O. We've selected the CPU. We have added our I/O. Everybody okay? Which would be the same thing. The only difference right now between RS Logic 500 is that we gave it a project first. So right now it's real similar, right? Then we're going to go to our project view. And so here's our project. Now remember, here's program. They call their main, where RS Logic 500 calls their main ladder 2. They call theirs OB1. Okay. And then up here, where it says add new blocks, that's where we would go and add additional subroutines if we needed those. So we'll go ahead and click on that. And now we can close this. The instruction set is over here on the right. So instead of having all those tabs on RS Logic 500, your entire instruction set that's available to you is over on the right. Here's your user, what they call user. This is your user menu up here. I'll show y'all how to add and take away from that on RS Logic 500. Here you just drag stuff off and drag stuff in that you want to add, which is pretty neat. They don't call theirs rungs, they call theirs networks. Are we okay? So by default it gives us one network, and we do the same thing. We pull it in and drag it down. It turns green where we can insert it. It automatically pops another network down there, which by the way won't be used. We can actually add more networks up there. I like this. The down drop, you can actually bring one down. Try to anyway, right here. And it just shows that, and then we can come up here and start just sticking items in here. And then when we're through, we just bring it up and close it up. You'll see that, and it looks a lot better than RS Logic 500, where it just sticks it out there in the center. And then we'll put a coil in here. We'll actually use one of our outputs. So notice it does not draw L2 because it takes for granted you what? You know it's there, right? So don't draw that like RS Logic 500 does. I think 5,000 does too. I'd like to show you 5,000, but for some reason my 5,000 has crashed. Now the way we address this is completely different than the way we address Allen Bradley's. In fact, I wish I had 5,000 going. The way you address IO on 5,000 is so complicated that you usually pull it in from a menu. I wish I had it going so I could show y'all. This is pretty similar to the way Allen Bradley works, but it's so on this one, if we want to put an input, we start off with I. Start off with I, so that's basically the same, right? And this means what? Inputs. Now on RSLogic 500, for outputs, we use an O, and the big problem with that is I even still do it. You get the O and the 0 confused with each other. So Siemens uses a Q for outputs. So that's a little different, but that's really easy to catch on to. Somebody in this class will put an O instead of a 0 or vice versa, right? You understand that? Then what we do, we put a byte number. Then we put a dot, which in RSLogic 500 is addressing a word, but in Siemens S7 it's addressing a bit, and then we'll put a bit number. So this is a bit number. That's a byte number. If we wanted to do a whole byte, we would go IB. We go IB, and this would stand for a byte. I'm dealing with a whole byte. Then we put a period, and then we'd put a byte number. So this is basically what you're dealing with. And I like this better because if you wanted to do a whole word, you'd say what? IW, which I really like. And then you put a word number. So the dot just separates what you're dealing with and what you're So if I was going to, so Q, then we'd put Q0 because I'm used to internal, and then we'll use 0. Oh, okay, this makes sense? So what's this? These are bit instructions. This is a byte number. And this right here would be the bit number within that byte. Oh. Are we okay? This makes sense. So I'm going to go here. I'm going to say input 0.0 I. And then the first thing it's going to ask me is it's going to ask me for a tag. So tags are kind of similar to symbols. Here, if you don't put a tag, it's going to put tag 1, tag 2, tag 3 in order. So it will put one in there, but over time, it's going to get very confusing trying to figure out what's what. So we'll come up here and I'll right click on it, and then I'm going to say rename tag, and then we'll call this start. And I'm going to change it. And then I'm going to overcall this. This is going to be input 0.1. Hit enter. By the way, you can set up the tag table. It's over here inside this. So down here, oops. Yeah, PLC tags. So what you can do is you can come in and set up your tag table before you even start. So it's just like in the RSLogic 500, we can set up our symbol table. And this is the way most programmers will do. They'll figure out what they need and they'll go ahead and set up these. And what advantage is using tags over addresses is that now you're dealing with names, right? That makes sense? So I'm going to come over here and I'm going to rename this tag. I'm going to call it stop. And then I'm going to come over here. I'm going to come over here. So outputs, we use Q, right? 0.0. And I'm going to edit this tag and I'll call this run. And I'll change. And now down here, I can just, what's nice about this, as soon as you type in the letter, the more you type in, it starts putting a table of the tags that's already available, which is really neat. So you can just start typing. And if you see it down there, I can finish it up. But if I see it down here, I can just come over here and click on it. Oops. Sorry. I messed up on that one, right? I can just type it in and then it pops up there for me. So this is our program, very similar to our program. Okay. We're using examine if opens because we're going to use normally close for our stop button, right? So the same thing there. Then if I wanted to send it to the PLC, I could come up here and here, right here, it says window. It says download to the device. We'll click on that. And if it can't communicate, this is what's so neat. If it can't communicate, it automatically brings up the application for you to find the same IP address, which is pretty neat. So on RSLogic 500, we would have to run that DHCP thing to do that. So we're going to start a search. And if it don't have any IP addresses out there, then it's going to come up here and show you the MAC address assigned to the PLC. Here we've got it though. So everything's okay. Found the PLC. I wish it didn't already have a MAC IP address. And then it's going to go through the process of loading. Then it pops up here and asking us to do some stuff. And this is why, because it's got another program in there. So what it's doing basically is telling me the program that I got in there does not match the program that I just wrote. So that gives you a second chance without wiping out your program, right? So here, consistent download. Let's see. So it wants us to stop. So we're going to stop the PLC, and then we can load it now. So the PLC was in run mode because it was running the other program. And of course, it's going to start the module, so we're going to finish. Let's close all this that's going on. So there's our module. What we'll do is here's where you can start the CPU. Here's you can stop the CPU. Very similar to what we're doing, right? Now on this one, it doesn't show you automatically on RSLogic 500. When you go online, it already pops up and gives you the view mode, right? It shows what contacts are enabled and disabled. On this one, we have to click on these little glasses up here. And what I like about this is it shows you the entire flow. So on RSLogic 500, all it shows you is what just turns the screen across contacts that are true. This one, it shows my stop is true because it's green, but my signal flow is stopping right there. So I'm going to come up here and just click the start button. Oops. So I'm going to click the start button and it's sealed in and my light turned on the front. So very similar, and what we're saying is that even though we're learning RS Logic 500, it would be very little learning curve for you to do what? For you to pick these up. Now, so this is real neat to see the symbol with the question mark. So that's the one I was telling you about, where if you pull this into the circuit, then you type in what instruction you want, but you still have to learn the mnemonics for all these different instructions. So on RS Logic 500, if I showed y'all the instruction palette, right? Did I show y'all that? Yeah. This PLC is not hooked up, so. And then now on this one, what we would do is if we had I/O, we would have to come up here and click on this, and then we would choose what type of I/O we had strapped on the side of that thing. By default, RS Logic, the TIA portal is going to go to that first, right? You understand that? So we don't have that. So on this one, here's your instruction palette. So basically, you can pull any instruction into this. Oops, from here. Oops, I got to insert a run first, huh? And we can pull any instruction into this. And then if you know the mnemonic down here, then all you have to do is right here, when you say change instruction type, you can come up here and type in any of these, and then it should switch over. Let's see if I can find one. And jump subroutine, and can you see what it did? So after a while, once you learn this palette, you won't use these tabs anymore. You'll just pull down like a contact, and you'll start typing in the instructions you want. And all you have to do is just learn the 3-digit acronyms they have down in here, and just say change instruction type and type in what you want, which is pretty neat. So there, I just wanted to show you all the similarities between these systems. So if you get into the TIA portal, then you'll see it would be what? It'd be a very short learning curve to go from RS Logic 500 over to how many programming classes do I have? Huh? None, yeah. So we bought a bunch of old Square Ds, which use dedicated terminals. This is before. This is where all your processing power used to be in the CPU on the PLC. And you just brought up a dumb terminal. You plugged into the PLC, and then you insert things. But now we program with an application, and this PLC keeps nothing. It's truly binary, which has really helped us manage the memory. And then I've moved up through these PLCs, but once I learned one, it was what? Yeah, we use the analogy about driving a car. Like when you go out and buy a brand new car, what do you got to do? You know how to drive it, you know what it does, but what do you got to do now? You got to figure out how to program the radio, right? You got to use all the bells and whistles, and then once you learn that, you have no problem. So we got a decision. We'll wait to see if some more people show up, but this is we're through with our lectures, so technically we could have test 3. We could do testing reviews been up there for quite a while since last class, I believe. So what we can do, if you prefer, is we can have test 3 this Wednesday, and then that would give you all the tests to study for the final exam. If we decide to keep test 3 on Monday, then you'll be studying. You need to play around with the PT1 and PT2. Test 1 and 2. And you have 1 day to make it over 3 on one class. That's what you're going to do. You won't be here much. Well, what is the rest of the class here? We'll talk about it. And the exam next Wednesday. We would. All we'll do on test 3. All we'll do on test 3. Give it on Monday. And once you take the test, we'll go from there. So if you test 3, that's fine. We'll get test 3. We'll be giving it the start of the class. You guys come in time. Next week, go over that. PT2 Simon this Wednesday, right? If I do that, all right, guys, ready to go to lab. By the way, if you haven't done what's the first required lab? The timer lab, right? Right. You need to go ahead and do what? Once you finish the lab you're on, are y'all listening to me? Once you finish the lab you're on, if you have not done that timer lab, you need to do it. Once you do that, what's the other required lab? The counter lab. You need to go ahead and do what?